Alright, we're back at it with day 2 of LeetCode grind. Solve or go home. 30 minutes solve or go home. Let's see.
Yes, but you're already home, so
Don't worry about it. I'm going home. Alright, let's see. What is
are
today's
you
question?
streaming? Where are you streaming?
Oh yeah, it's twitch.tv's. Wait, I just sent it to you. And it's this. What the hell is this? Okay. Design
No,
implementation of
read.
circular queue. Oh, great. Circular queue. Oh, wait, let me start the timer. Alright, so circular queue is linear data structure in which operations are performed based on FIFO. Okay, first in, first out, easy.
You know that.
Ring buffer. What the hell is this shit? One of the benefits of a circular queue is that we can make use of the spaces in front of the queue. In a normal queue, once the queue becomes full, we cannot insert the next element even if the space is in front of the queue. By using circular queue, we can use the space. Wait, what? You cannot insert the next element even if the space in front if there wait, what, how, when does the queue become full? Like when you allocate size to it?
Yeah.
Yeah, but then that's, no one uses that. Everyone uses array list, right? There's no space. Like, there's no full queues, is there? I guess this is more like a C problem.
No, you can do it in Python.
No, I mean like the allocation issue. In Python, there's no space allocation problem. You can always insert into the array, right?
Right.
Yeah. So this is a weird use case, I guess. But I guess they just
Yeah.
want to implement it. Okay, so using circular, we can use the space. Okay, so what is a circular, first of all? It says the last position is connected back to the first position to make a circle. And it's called a ring buffer. I don't understand the point of this. So this is once queue is full, we cannot insert. By using circle queue, we can use the space. What space are you talking about? They're replacing the first element with the new value? That doesn't make sense. Hello?
Right. Right.
Do you know what they're asking? I don't really understand what they're trying to do here.
Uh, I'm from based on the okay. So last position connected first to make a circle. Then it's a ring buffer. One of the benefits is that we can make use of spaces in front of the queue. Uh,
Is it literally like what's the point of the circular nature? It's just saying you can insert into the front of the queue, right? Making it a stack. I don't
oh, I
understand.
see. I see.
I don't
I
understand
see.
the point of the
Well,
circularness.
oh, okay. I understand. Okay. So let's say you have a queue of size 5, right?
Yeah,
And then you add numbers 1, 2, 3, 4, 5 into this queue, right?
yeah, sure.
So when you try to add number 6, right?
Yeah,
It's full
yeah.
because you're already at size 5, right? But
Yeah.
what happens is I guess you want to have it stack on top of where 1 would be.
Yeah, but like, what do you mean by stack? You can't. How do you even stack stuff?
Well, that's the thing. That's how you design it, right? So
Wait,
it's
that doesn't
really
make sense.
no. It does make sense. So the way the structure would be designed would be something like you would have to have the ability to have more than one element at each
Oh,
location.
okay. Okay, that's what you mean. Okay, okay. So you need to be able to store more than one element into each position of the queue, and also you need to be
Correct.
able to maintain the pointer,
What
like
order?
which
The
one
order
goes,
of what
which the
was?
order of it. Yeah, you have to maintain the order of
Yeah,
it.
yeah.
Oh, okay.
Hmm.
So what? Maybe first off, thinking like maybe like an array within each slot.
Yeah. That's a good start.
Okay. All right. So I would have to implement. I have to implement the whole thing. Okay, okay. So this is
All
NQ.
right.
Wait. Where did
So
my circular queue initializes? Do I have to implement that too? Oh no, that's already
you have
implemented.
to
Oh,
you have to
actually, do I
implement
have to
it.
implement that? Okay.
And it is going to be the main data structure,
Okay.
and
So
then the
it's
other operations work on this data structure.
all right. So I have to implement
Oh,
the object with size of the queue to be k. So in Python, so I have to enforce the size of it. Does Python even allow me to enforce the size of an array?
Yeah. I mean, it could be like you know,
Oh,
something for I
I could
in
just do
range.
like an if check, right? Like if it's over that, you cannot insert it. To, you cannot.
No.
Oh.
That's not it, right? You're initializing your array, your self dot
Mm.
queue to be size k, right?
Yeah,
So
I
that means
understand that. Yeah, but then like in Python, you can't really enforce not letting it like implement like when you try to like. Well, I guess technically we're not really using the push and whatever commands. We're building our own pushes, right? Yeah, so I guess it doesn't matter.
right, but you still need to do the initialize
Yeah,
thing
yeah. Okay,
for
so
size k.
first off, the self dot r
Mhm.
equals that what times k, I think. What initialize? Do we are these like ints or something? What are these? These are ints, right? It looks like these are ints. So I think should I just do 0 to initialize for, or should I just
I don't think you should do 0 because
that?
otherwise
Yeah, it would break stuff, right?
when
Wait, how
they
do you do
add
it empty then? Is it just like empty bracket
empty,
times
yeah,
empty times k
yeah,
is fine? Okay,
right.
so let's do,
But you probably you want to be able to index it, right?
uh yeah, but then we're inserting the arrays later, right? So do you mean like that?
So I think you want a wrapper around this that is an array as well.
What do you mean by another wrapper?
So you want this, so this is right, except the k should be inside the first brackets.
Like that? Wait, are you sure? That doesn't
Well,
make sense.
no, well, it's basically for I in range k, right?
Yeah, okay, wait, but my thinking is you want size k to be the array, right? So the array.
Yeah. So basically, you're initializing k empty arrays inside this array.
Oh yeah. Yeah, you're right. Yeah, yeah, that's what I'm trying to do.
So
Okay,
do it for I in or for underscore in range k because you don't care about.
wait for underscore that.
Oh no, well no, you want the empty.
I have no idea this Python syntax.
Okay, underscore doesn't matter. Underscore means that it's a throwaway index.
Okay, yeah, but so what the hell am I looking at?
Oh no, so you want an array, and you
Yeah,
said you want empty arrays inside this array,
yeah. So wasn't that previous
but you
implementation?
want k of these.
Yes.
So
So if you multiply by k, doesn't that do that?
it might actually. Let me try it.
Why don't you just print it? What the hell? Indentation error.
No, I don't think it does anything.
Oh.
Because then it's empty times 3 is still empty, right?
Okay,
Yeah.
then what kind of syntax are you supposed to use for this?
The indexing syntax.
Yeah, but I don't know that. Do I have to Google
Oh,
this?
yeah, you do. It's for I in range k.
No, no. Yeah, I know how to loop, but I don't know how to build an
Oh,
array
the
in a
loop is
loop.
fine also. Okay, if you don't want to do list comprehensive, that's fine.
Wait, what?
No, just say no. So self array is empty array, right? And then for I in range k,
Oh, just build it
uh,
after? Okay.
and yeah,
R dot push. Like that?
you need to parentheses around. No, it's not that push. It's that append.
Oh, my bad. Yeah, that's JavaScript syntax. Wait, there is a parentheses. Isn't this fine?
In line 5, you need parentheses around the k.
Oh, oh yeah, yeah, yeah. Okay, yeah, yeah, yeah. Okay. How do I comment all this
Right.
crap out?
Okay, cool. So you have the array.
Yeah, I want to print to make sure it even like looks properly first.
No, you can't. Well, you can't print it unless you call the thing.
No, the init runs on init, right? It should be fine.
Oh, sure. And
Oh,
it's gonna break when it tries
self.
to call a different thing.
No,
Self.r.
yeah, I just did that. Okay, yeah, so that looks correct.
Yeah, great.
All right, so we have the
Okay.
array now. Okay, that's fine. Okay, so let's build the front, get the front item from the queue. If the queue is empty, return -1. Okay. So, alright. Actually, I'm gonna comment all the ones I'm not working out so it doesn't break, and I can test each one as I go. Alright, so front, like, so it will say return the front item from the queue. If the queue is empty, return -1. Okay, so the front item of a queue is the first index, right?
0, I guess.
Yeah, so it would return. So it will return self.r 0 0.
Yes, assuming
0 exists. So I would be like if self.r 0.
Well, they're telling you to call the isEmpty
Wait,
API.
what are you talking about? Where there's an isEmpty? Oh,
To them.
I'll have to implement it. Okay, my bad. All right, so
Right.
let's do that one first. So if self.r is empty. Wait, actually no. It's just
Also, if you
is
don't want it
empty.
to just break, you could just type pass for everything. Right.
Wait.
So
Say that again. What do you do?
if you don't want your code to break, you can just add pass
Like
at
that?
the end of every method.
Like literally just pass like that?
Yeah.
Oh,
yeah. So
okay, that's
basically, it skips it.
Oh, I didn't know this. I don't know Python much. I just use it for coding. I mean, not for
Yeah,
coding.
that's
I
fine.
just use it for LeetCode, so I have no idea. All right.
That's fine.
Is empty self.r. Wait. No, this takes a self. So I don't think.
No. If self dot is empty. Or sorry,
Yeah,
if
yeah, self dot
R-
array that. Okay, yeah, that's what I'm thinking. Okay, yeah, so I was right before. Okay, self dot r. Because yeah, this thing. Oh, it just takes self, but it doesn't do anything. Okay, that's fine.
no, then you don't need the R. It's just self dot is empty. It's fine.
Wait,
Because
what?
self dot R is already. So the R is already accessible in this class because it's inside of self.
Okay, yeah, but then yeah, so when you come in here,
Yeah.
do you still have to call it self.r? Right? You can't just do r, right? It doesn't know what it is, right?
Alright.
Okay, alright. So so self that is empty is just calling the function because it's within self, right?
That's right. All of this
okay.
is within the
Alright,
master code queue.
I got it. Yeah, this Python's still weird. Okay, whatever. Okay, is empty. So if I think you just do a len check, right?
Well, can you? Because you have length k already.
What do you mean? Oh yeah, you just check k, right?
No. You're initializing it so that the length will be k if you're doing a length check.
Mm-hmm.
So it will never give you.
Wait,
0.
hold on. Oh, DQ removes stuff from it. Yeah, no, then you're supposed to be doing the len check. The K is useless because then you're removing stuff from it, right?
No. You're removing stuff.
Oh,
From,
you're just removing an element. You're not removing the actual.
Yeah, the queue itself.
Oh,
is still the
okay,
same
okay. So what we want to do is to check to see if there's elements within the thing. So that
Right.
we have to
So
loop through the
maybe
whole
you want
thing.
to
So okay, so
maybe you
so
want to keep track of that. How many elements you've added and such.
I could do that. So that would be more optimized than looping through the right each time. Yeah, that makes sense. Okay, so self dot elements equals k currently, and then if in DQ, I would remove it.
No. Self elements is 0. It's not k, right?
Oh yeah, you're right. That's 0.
At the beginning, you're just initializing. Self dot size is k or whatever, right? But that's fine.
Yeah, size is useless. We don't care about that. Self dot elements plus equals 1, and then this one should be wait, NQ should be no DQ is minus equals 1. NQ should be plus equals 1. So is empty is return self dot elements. If it's greater than 1, otherwise it's -1, I believe. Is empty checks. Oh no, it's just a boolean. Never mind. So it just returns suffer element greater than 0. Yeah, I think if it's greater than 0, that means it's not empty. So that should be correct.
Wait. So if you have one element, then you're gonna say it's empty, right?
Oh, my bad. It should be less than 1. Yeah, that's opposite logic. Okay, that should work.
Okay.
Okay, so if it's empty, wait, let's see, what was the logic for this one? Wait, which one I'm doing? I'm doing front. Okay, get the front. If it's empty, return -1. Okay, so if it's not empty, else just return -1. Actually, I could probably do this in the ternary.
That's fine. That's fine.
Return.
Be careful with your array index.
Yeah, I need to fix that logic. I'm not done yet. Return. Shit, I forgot the code to do the ternary in Python.
You don't need the ternary. You just do return -1.
Whatever. I'll fix it later. Clean up. Alright, so if it's not empty, that means there's stuff in here. Okay, so I need to check if there isn't even an element in the first position.
No, if it's not empty, for sure the first element has some.
Yeah, but then we're not guaranteed. Oh no, you're right. Alright, so if it's not empty, no, you're not guaranteed something in the first spot, right?
Yeah, you are. Because that's by definition how it is added.
Okay. Oh yeah, you always add to the first spot and then you remove from the last spot, right? Wait, no. This is a queue. You insert at the end spot and you remove from the first spot, right?
Well, technically, you insert in whatever self.elements count is, right? So let's use the 1, 2, 3, 4, 5 example, right?
Yeah.
So you insert 1 into position 1 because at that time elements is 0. So you're like, oh, okay, the first guy should go here. Then the second one goes to the next one, and the third one goes to the next one, right? And then when you get to the fifth one, then you're like, okay, I'm full now. And then number 6 goes back around to 1, right?
Yeah. Okay, I get that. But then like,
so when you're at, so the front is always going to be the first value. The first position.
Yeah, for sure. Okay, but then the front is always the first position and the first element in the array of the first position.
So you know exactly how to get the front.
No, yeah, I know.
0.
Yeah, it's not possible that it's empty, right? If it's not empty,
you literally check.
No, I know. I mean, like, if it's not empty, that's not possible for the front to be empty, right? Yeah.
That is correct.
Wait, then that should have been correct. Self.r0, 0. Right? That should be good.
No, the syntax here is wrong.
Wait, what's wrong with the syntax?
Because you're to access it. Okay, so index 0 of 0 is not a thing. It should be the 2 brackets next to each other.
Oh, oops, yo, oh my god, yeah. I don't even know, what the hell, how do you, okay, yeah. Wait, no, this means it's a 2D array, right?
Well, that basically is, right? So the first indexes into the array at position 0, and then the second index is that payload at position 0.
Yeah, okay, so this should work. That should be
good.
correct.
Okay.
Rare is the last one. Get the last element, else return -1. Okay, so rare is if it's not empty, then if it's not empty, you're not guaranteed to have. Well, I guess you are guaranteed some in the back, right? It's just where in the back it is, because then it could be the front position. So I think using elements count, we can kind of figure out where the rare is, because then
you can definitely figure it out.
Using the rare, we can subtract k to figure out, like, we kind of do a mod on k to figure out what
that's
index,
a very good idea.
Yeah, what index
I agree with that.
Okay, so then you can do I think self. So index equals self.elements mod k, and then you would just return.
Okay, where's k? You need to store. Or
we never stored it. Yeah, you're right.
Well, you kind of have it. It's length of self r, right?
Oh yeah, you can just do that. Yeah. And then if not empty, well, actually, we should just probably check it beforehand, so you don't have to do this logic if it's empty. and then same as before, else -1. Then if that means, then you just return self.r index. Wait, no, not index. Is it? Wait, the index will pull you the correct.
Okay, it will get you the correct mod bucket, I guess.
Yeah, the bucket, but you don't know the correct index to pull it from.
Oh, it's the last so one, right?
Wait, no, it can't be the last one. Okay, so let's say in your example 1, 2, 3, 4, 5, right? And you have a 6 in the first the element 0, right? So
yep.
Oh, what the hell? Did I refresh page by accident? Oh, okay. Yeah, so if you're in 6, that means 6 mod 5 is 1. So that means the position is 1, right?
Okay, so something's off by 1 in your modding here.
Why is it? Well, okay, wait. So you're saying that the mod logic is incorrect?
The mod logic is it's a good idea, but you have to be careful with the.
You have to fix it, but then the main gist of it is that the mod will get you kind of what you're looking for, right?
All right. So after you add 6 elements, the first position will have 1, 6, and the second one will have 2, and then the third one will have 3, the fourth one will have 4, and the last one will be 5, right?
Yeah.
So in 1, 6, how do you know what the last element is?
Well, the last element is the last element of the array. Oh, so
exactly.
So the index is. Oh, okay. I think I got you. So I need the mod supposed to get me which index, and then I just pull the last element of that
Exactly.
Array. Okay, so
just make sure the index is correct.
So the index currently is elements is 6, mod 5 is 1, which is incorrect. So I think you have to do a -1. Does that clean it? Let me do another example. So let's say I had 7 elements. If I had 7 elements, then we want that second one of the second index. So 7 mod 5 is 2. So 2 is going to pull from index 2, which is incorrect. It's supposed to pull from index 1. So I think -1 should clean that up.
But -1 should happen probably before you mod it, right? Because now your mod could be -1.
Oh yeah, you're right. Okay, so elements -1 mod that. Okay, I think that works.
Okay, yeah, that's one.
So return self.r index, and then the last one, which is len. The last one is the len -1, -1, right? -1. That works. Does -1 pull the last one?
Yeah.
Okay, cool. All right, so we got rear done, I think. What do we need? Oh, is full is easy. Let's check that one quickly. Return self.elements equals len self.r. Alright, so I have DQ.
Not quite.
Wait, why not?
Because what if you have more?
Oh, wait. Full check isn't check to see if. Full just means if it's greater than the length of r, I think.
Or equal to.
Yeah, greater or equal, yeah. Alright, that's what full means. My bad. Yeah, I was thinking incorrectly. Okay, cool.
Okay.
Alright,
need 2 more.
In queue, insert an element into circular array, return true if array successful. Okay, I'm assuming they wanted me to use the full thing. So yeah, so before this, I'm going to check to see if it's full. So if it's full, we don't want to insert normally. Honestly, do we even need to check that? I thought.
Oh, it doesn't even matter.
Yeah, if we just do modulars, I think you always insert into the correct position, right? So if I
you know exactly where to.
Yeah, if I want to do for knowing my current elements, so if I want to do for 5, I'm trying to insert 6. I'm gonna do. It's gonna be number of elements mod k. So Well, it would be 5 minus 1, which 4 mod 5. Wait, no, I think you have to add the current element first that you're trying to add to the. Okay, so I think you do it after self.elements plus 1, and then you just do index equals shit. What is it? Oh shit. Self.elements minus 1 mod len self.r. So like in this scenario, if you're inserting 6 elements, you would pre-add 1 because that's the one you want to try to add. So that's 6. I guess technically you don't have to pre-add and just get rid of this -1, and that would work. Just make it cleaner. Yeah. Okay. So if you do index equals self.elements mod length. Okay, so if you're inserting 6, right now you have 5 elements, you're going to mod the length, which 5 mod 5 is 0. So it's going to insert into position 0. So you're just going to do, what is it? Self.r 0 dot append a value.
Oh, wait, what's 0?
Oh, not 0. What am I? Index. Okay, I think that works.
You say something and then you do something else. I was like, what?
Dude, when you're typing on LeetCode, that's what happens, man. Okay, I think that works. Okay, so yeah, so if you're inserting 6, you're inserting index 0. So you grab index 0 and then you append it. Okay, and then you add increment elements by 1. That's fine. If you're inserting 7, then at this point you'll have 6 elements. Mod the length of this array is currently 6. So wait. No, length is always 5. My bad. What am I talking about? Yeah, so 7, it would be 6 mod 5 is 1. So you insert an index 1. Okay, I think that works.
Okay.
Alright, so DQ is deletes an element from circular queue, return true if the operation is successful. Oh, I need to return, my bad, I need to return this. I mean, this always works. There's no, I think you just return true straight up. There's no failing in an in-queue, I don't think.
What?
Is there even a failing in I guess there is a failing delete if there's nothing there, if it's empty.
Exactly.
Yeah, so if it's you can just do a check. Return what if self.empty return false. And then you just do else. Alright, and then alright, so to remove from the thing, okay, so you just need to find, wait, when you're removing, I believe you're removing the first one? Deletes an element from the circle queue. No, oh, this one is a specific element? Is that what it is?
Oh, sorry.
Wait, no. Deletes an element, but it just says deletes a element. But in a regular queue, you're deleting the first thing, right?
Ah, interesting. So
wait, but this doesn't, like, this isn't specifying what's going to happen because it just says deletes an element. It doesn't even pass in an element. It doesn't, like, if it's passing an element, then it makes sense you delete the specific element they want. But then it just says deletes an element. It doesn't specify if it's the first one.
Oh, it's probably the first one.
It should be the first one, right? That's how a queue works. Do I just assume that's what they're talking about? I mean, I guess we could test it, but yeah. Alright, so yeah, if you're deleting the first element, then you just grab front, right?
Oh, then front has to change, I think. Yeah, you're correct. It should grab front, but
oh, should in queue be inserting the rear? Wait, actually no, you're not. You don't need to grab the rear.
Yeah. So you see the problem, right? Like if you queue a bunch of times, then front is no longer 0, right? It's gonna be something.
Yeah, I see the problem here too. Yeah, if you DQ a bunch of times, you're removing all the front stuff, and
I
then
think you need to somehow keep track of where you
the
are,
current
where the
front. Yeah, the current front. The
yeah,
the so you just need a pointer at the current front then, right?
correct.
Okay, that's fine. But okay, so if you dequeue too many times, that means your head just keeps changing, which is fine, right?
Yes,
It doesn't really matter. It doesn't change the logic of the queue, right? That should be fine.
that's right.
So yeah, so self dot head. Oh shit, the timer's out. I'm done.
Good time.
I'll
Okay.
finish it. I'll finish this. It's close. So I guess I'm going home today. I lost.
Yeah.
Self dot head equals you want the front of the array 0 0. That's the current head. Okay, and then when you enqueue, you don't change the head. Only when you dequeue, you change the head. Okay, that's fine. So we want to grab the head and remove it. So
No, no, no. I don't think you want the head. I think you want like which mod you're at, right? Starts at 0, but
wait,
will
why do
probably
you want the
change
mod?
because when you pop the head, like you still want to replace the head.
Yeah, eventually. No, no, the head is just a pointer to what's currently the front of the line, right?
Correct.
Yeah, so
But if you DQ once, then you have to run front again,
front,
right?
when you run front, it just returns. Front shouldn't return self dart. It should return head, right?
Yes.
Okay, that's fine. And then yeah, but then when you DQ, after you DQ, you just recall front, and then you have a new head. You should be fine. Wait, no, this doesn't modify head. This just
Yeah,
returns
this
it.
is the
So
modifier.
I have to
That's the problem.
modify and DQ then. Yeah.
No, no. So when you DQ, your cursor changes, right? So it should be self.cursor.0 or something, right?
Self. Well, the head, right? So if I'm DQing, right? So in the an array of 1, 2, 3, 4, 5, and you have 6. So if I'm DQing, I'm gonna pull out 6, right? Wait, no, I'm not pulling out 6. I'm pulling out 1. So head currently is 0 0. I pulled it out, and then
So now
I
head is
repoint head to 1 0 now.
yeah 1 0.
So
That's
head
right.
is 1 0 now. So that's fine. So in DQ, I'm constantly pulling the head, removing it, and then repointing to the next head.
Yeah, but where is front updated? It's not.
Front doesn't need to be updated, right? Front, when people call front, then it updates. But then it's just a function. It's not like it needs to be called, right?
Okay. Okay. That's fine. That's fine.
I mean, if that's the if they really want me to use front in DQ, then sure I have to handle that. But then this is just a method that they're calling.
Well, I think they do want you to use front and DQ because you find the front and then you pop that guy.
That's true. They probably do want that. They don't really mention that. See, this is
Well,
delete.
why would they make you implement it if?
Yeah, I guess. All right, fine. If I need to update front, then I need. Oh, so then I should do the logic in front then.
No, so it should just return self.cursor
What is cursor?
of 0, like where you are in the circle. So it's gonna be 0 1 2 3 4 0 1 2 3 4 etc. Right? It's gonna cycle like that.
I'm not sure what you're saying.
So at the beginning, front is pointing at the 0th element. And then
Yes.
as you add stuff, front is still pointing at the 0th
Yes.
element.
Yes.
But as you DQ stuff, it
Mm-hmm.
starts pointing at 1, then 2, then
Yeah.
3, then 4,
Yeah.
then back to 0.
Mm-hmm.
Right?
Yeah. Yeah. But the thing is,
So then where you are in that cycle is your cursor.
where you are in that cycle is the cursor. Yeah. Isn't that just? So we have to. So we need to also store that too.
I think that's a good idea, but maybe it's not necessary. We'll see how you do without it.
Okay. Wait. So if I quick thing. So if I DQ, I should pull the head first. So I should say I guess like
You should look for front, and then
remove remove equals self.front, and then remove it, and then and then it'll be like remove. Wait, how do you clean an element? How do you make it empty? You just set it to nothing equals null or something. Remove that. So this would return the head. So remove just equals null. Can you just do that? None.
No. You do self.array.front 0.pop or something, right?
Well, you can't pop it, right? Oh, actually, no, we can because these are arrays, so we can pop them. Oh, this is an int. Okay, so you can't even return self.head. Self.head is the actual element. That's why. So okay, front we're tracking should be the position that you're trying to pop.
Right. In fact, front and rear you don't really care about, right?
Well, what do you mean?
Actually, no. They might check on that. Never mind. I think it's a good idea to use.
They probably want you to use it, so I have to probably fix NQ also, which is annoying.
No, it's gonna be analogous. So you want self.array of probably self.cursor and then 0.
When you say cursor, you mean the index, right?
Yeah, or index, sure.
Alright, so I'm just gonna do index equals self.elements minus 1 add. Wait, no, that's the rear. If I want the front, it's the first element, so it should be the opposite way. Number of elements is 5. So if I have 5 elements and 5, it should just straight up be mod. I think that's it, right? Because if I had 6 elements, that'd be position 1. Oh no, that's wrong. That just gets me the first index of the array, which is not what I want. Front should be
I think you need to keep it offset somewhere. Even for rear, I think. Because the number of elements will change, and then if you don't have that offset, you won't know where you are.
What do you mean by offset?
Now, let's say you have 1, 2, 3, 4, 5, 6, but then let's say you added 1 and then you dequeued 1, right? And then you did 2, 3, 4, 5, 6. So technically, front would be 2 at position 1, and then rear would be 6 at position 2, but the size of elements is 5. So you would never find it.
I didn't fully follow that. Okay.
No. So what happens? Let's do in Q1 DQ1, then in Q2 3 4 5 6. What is front and what is rear?
Did you just say in Q1 DQ1? Huh?
Yeah.
Okay, so if you're in Q1, then you have one.
Draw your array. Draw your array of size 5.
Let me draw my array of size 5.
Just do a comment or something at the bottom.
So in Q1, then it's currently only 1. Then if you dequeue it, then it's just empty. And then now you say
the array currently looks like empty array.
Yeah, empty.
5 empty arrays.
It'll be 1, 2, 3, 4, 5. and then if you enqueued one, be one in here, and if you dequeued it, it'd just be the empties again.
Right.
Okay. And now you said 2, 3, 4, 5, right?
Right.
So in the current logic, 2 would go in here. It wouldn't go in here, which is supposed to go in here. Is that what you're saying?
I'm saying this is the correct logic, actually, because you're going into the next element in the queue.
Even though you dequeued one.
Oh, okay. Maybe not.
If you dequeued one, it should.
You're right.
If you removed it, the new head points back to
here,
here,
fine.
right?
Do 1, 2, 3, 4, 5, 6, and then DQ 1. And just change the first line. Don't bother with. Yeah.
Okay. If you DQ 1,
Mm-hmm.
then 1 is gone.
Yes.
And then what?
So what is front and what is rear?
Front should be 2, rear should be 6. But I think
according to your calculations here,
it's both in here. I think. Oh, I'm not even too sure right now. I'm not even following my current logic right now.
Right. So for us to have front is 1 and rear is 0, or rear is 6, I guess. We have to have the offset be 1, right? We're basically we have to say that, oh, we dequeued 1, so the offset is 1 now. Because otherwise it would pick up 6 as front, which is not true. Does that make sense?
Kind of, not really.
Every time you dequeue, you should add to the offset.
So the offset is just, you're just incrementing it every time you dequeue, so you know what position.
What position the actual head is at.
Yeah. Okay. Yeah. Yeah. You're supposed to increment. Wait. What? Were you talking about NQ or DQ?
DQ.
Yeah. Every time you DQ, you're supposed to shift it. Yeah. I was trying to write logic for that.
Right, but it's hard to do that without keeping track of how it shifts.
Keeping track of what?
Of the offset.
Is it? Okay. So.
Like, how do you know to look at position 1 now? You don't. And how do you know that the next element should be added at position 1? You also don't.
So in this scenario, when you popped 1, the front will still think 6 is the front. So you're saying if I DQ and I just shift it over index, then it will know that it should start pointing from the first index.
All right. So what you want, in fact, is for you to have a self.offset and a self.elements, and then the sum of those gives you the correct actual location, right?
Of the front.
Of the front and the rear.
Yeah. Okay.
Well, the front is just self.offset, and the rear is self.offset plus self.elements.
Okay. So every time you DQ, you increment
off.
And then when you NQ, do I need to change update that? No, the offset is only for tracking the head, right? I don't think you need to decrease that.
And the rear.
Okay, so. Alright, so if I have 6 elements and the offset is 0, that means you know the last element is just
6. Exactly.
6. because wait, so
Because you didn't DQ anything, so you're still starting at 0.
wait, so if I was like this and I do rare, right, I want this, so then if it's not empty index blah blah blah.
You want self element plus self offset -1.
Wait, why do I need a minus the offset?
No, you don't minus the offset. You want the plus the offset.
Oh wait, so alright, so if offset was 1 in this scenario, offset is 1, and you want the rare, because there's 5 elements now. The rare should be 5. So in this scenario, elements is 5.
Why would the offset be 1 here?
Because I removed 6. I mean, I didn't remove 6 one time. I removed 1. So 6 is the rare.
Correct.
So offsets. Okay, so elements would be 5 elements minus offset of plus offset of 1, which would be 6. Minus 1 is 5. 5 mod. Oh, okay, so that does put me in the 0th index. Okay, so that, yeah, that's correct. So self offset. Also, this is wrong because it's supposed to return. I think we're just returning the index here. What am I doing?
Oh, that's fine.
No, rare is supposed to return an int. Oh wait, no. Oh no, no, it's the actual last item. My bad. Oops.
Yeah, that's fine.
Okay. Wait, then wait. Yeah, it's
fine.
Yeah, I'm still returning the last. Okay, that's fine. Okay, so and then so the front is self.
It's very similar, right?
Mod. Okay, so in the front scenario right here, the front is 2. So if I do index of self element, so there's 5 elements now. 5 mod 5 is, yeah, so that's wrong. So I have to add the offset, which would be 1 in this scenario, and that'll put me here. So that'll be 5 plus 1 is 6. 6 mod 5 is 1, so that puts me there. And then the front should be, and then I should return.
Why do we care about elements in the front? Why do you care about elements in the front?
What do you mean? You're saying just use the offset?
Yeah.
I mean, I guess you could. Yeah, I guess technically you don't even need the mod. It's just offset.
No, you do need the mod because let's say offset is 6. If you DQ like 6 things.
Oh yeah, you're right.
Then you're not going to be able to index 6.
Okay. So then you just want to turn self.r index 0.
Correct. Okay, this is good.
Okay, so to fix this, okay, so I get the front and I remove it. So let's just grab that first. So self.front, I have self.front. And then like to remove it.
Well, you don't actually need self.front. You need self.offset, really.
Yeah, that's what I'm saying. So this doesn't make sense because you can't really use the front method to solve this method.
Correct. There should be an actual
front shouldn't return the element. It should return the index. So you know what?
Yeah, but that's not what they want. They're not gonna check on that. So we
yeah,
want
I know.
front, not front element. So maybe you want to make a second definition that's called in both def front index or something.
Yeah, you can def your own. They're not gonna call it, right?
Yeah, they're not gonna call it
front helper. So this one just returns the index. So I'll just do if not self is empty, return self.offset mod run. Oh, wait, I guess there's no need for else here. And then you
No, there's a. It's -1.
no, that it's a helper. We don't. It's only going to trigger in this
No,
case.
still, but if
No,
it's
no, no.
empty,
You know, it's not going to matter because look, this stuff only happens when it's not empty. So this code won't be. I mean, I guess you can check for it, but it's not going to be called. The front helper is only going to be called in this section where itself is empty.
okay.
Oh, I guess yeah. I don't even need to check then. I just return it straight up. And then I just call it here where index equals front helper. And that's it. And that should work. And then I can call it here too. Index equals front helper. So I have the index I want to remove. And then I just do self.r index equals to none. Or no, I just literally just pop it out, right?
Yeah. Dot pop 0.
Oh, you have to specify index.
Otherwise, it pops the last guy. You
Oh,
don't want
okay.
to pop the.
Okay, yeah, that works. Okay. And I guess I could do a rare helper so I can use it. And then just return
It's very modular now.
this. And then just call it here. Honestly, just make it smaller. Okay. Yeah, and then I think that's fine. And then so DQ I would have to fix it to no NQ. So index would equals self dot rare helper. Well, I guess I would have to increment elements first to use that. So rare helper would -1. Does this work? Okay, so in this scenario, if I had this, that means this is the front, this is the back, and then I'm trying to NQ 7, let's say. So elements right now is 5, it would be 6. Then I'll jump into rare helper 6 plus offset. What's offset is 1, so it's 7 minus 1 is 6. 6 mod 5 is 2. So it
No, 6.5 is 1.
did I just say 6? Wait. So this one's element is 5, right? Yeah, 5. Offset is 1. 6 minus 1 is 5. 5 mod 5 is 0. So 0 inserted here, which is incorrect. Should insert it here. So
No. Wait. Rare helper will give you 0, right?
Yeah, so that's wrong, right?
No, that's right. Because the last position is 6 right now.
Oh,
So when you NQ, you Q to the one after that.
Q.
Yeah,
Yeah,
helper is doing the.
you're supposed to insert it at the last position. Okay. So the last position would be here. Okay, yeah, so that might be
Which is why you do the +1 before you call it.
Yeah. Yeah, that's why I had to fix that because this one is different. But then I was just checking it. Okay, so if that's true, then this will just append it and return true. So does that work? I think that's good.
It looks fine. You have to return. Yeah. Okay. No, try it.
The only problem is if they don't like that stuff. Oh, what the hell? Why do I even have a head? I don't need this.
Oh yeah, that's not right. Don't do that.
Index append is apparently out of range. Okay.
For which operation?
Oh, NQ. I guess I just print it out then. Let's see what's up. Let's see what value they're trying to insert to. So apparently failed at 3, 4. Index 3. Value 4. How does that fail? Solf to R3 would be this? Yeah, this.
Print R also. Print R.
Oh yeah. Oh, maybe the popping it broke it or something? But it didn't pop yet, did it? Maybe it popped. Oh wait, it should be Solf.R. Oh yeah, this array is short. What the hell? Why is there only 3 elements? Oh, maybe if you pop it, it just pops the entire array? Which is bad.
No. Where's the pop? Hang on, scroll up.
0, 1. What's K?
So print array at the beginning. Just so we know the size of the thing.
Oh, why is it only 3 elements in this test case?
Should be 4, right?
This one is, what's K? It doesn't tell you. Input, yeah, the input doesn't even specify a K. Unless their K is wrong. Maybe it's K plus 1? Does that fix it?
No, it's 3. No, it's 3. Scroll up. No. That is definitely wrong. 100% wrong. It's supposed to be 3 elements.
Okay. Wait, how do you know it's 3? Where does this say that?
You see line explanation line 1. My circular queue 3.
Oh, okay, I see. Alright. Then, why is it out of range?
Well, because you're trying to index number 4 out of a thing that's 3. So, okay. 1 sec. Scroll down.
Oh yeah, this is index 3.
You're adding 1, 2, 3, okay. And then what are you doing? You're enqueuing 4.
Yeah. 4's supposed to go in here.
So you're enqueuing 4. Okay, so scroll up.
Rear helper returns 3. Why does it return 3? Returns the helper. So elements right now is 3 plus offset is probably 0. Right? 3 plus 0 minus 1.
Oh, can you put the whole thing in parentheses?
What? Oh, this thing?
Yeah.
Before the mod, right?
Yeah.
Yeah, that might be something. Oh, there you go. Is that correct? Oh yeah, that's not correct.
NQ. Where's... Wait, what is the 4th thing? 1, 2. Why is it a false?
They expect a false.
From NQ? Oh shit. Oh,
Whoa,
is it
wait.
not supposed to let you?
Insert an element, return true. I thought it's supposed to allow you to put it in. Oh, so they don't want it to
Oh,
stack. They just if it's full, you
oh, I
can't
see, I see, I
insert.
see, I see, yes. Ah, okay, sorry, I misunderstood.
Yeah, me too. Then we coded all this for no reason. Okay, so
No, 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 no,
basically what they're
we
saying
did.
is they don't want it to stack. It should only be one element per that position,
I see, I see.
right? Is that what
Okay,
you're
so the rest
saying?
of the logic works. The rest of the logic works, but basically, if something's already there, you should not.
Then we don't even care about the array of arrays. It's literally just an array.
Correct, correct.
So we don't need this
Okay,
shit.
so you did the complex version of this.
Oh my god. So we just misread this shit. All right. So in that scenario, then we don't need. We literally shit. All right. How do I fix this quickly? Self elements greater than or equal to the length of self.
No, just should be equal.
Yeah. And then we don't want this, right? We don't care about offset.
No, we do care about offset.
Do we care about offset still? Oh, because if you're popping, I guess you still care about offset. Yeah, you're right. Yeah, we don't care about this because there's only one element per. We don't care about this.
Okay,
Either.
so a ghetto way to do this is just keep the same code,
Yeah.
and then you know,
Just
you
remove
replace
the second indexes or the
you
array
just
of
replace
array stuff.
So basically, if the length is greater than one, then you don't do it.
Yeah.
Right?
So if we're popping, we don't pop 0. We just pop. No,
No, you can pop zero.
Hmm? You can pop an element. Don't we just aren't we just popping index instead? Self.array dot pop index. Right?
Oh, so you're changing the code. Okay, that's fine.
I'm not fully changing. I'm just fixing the stuff that thinks it's array of array, right?
Wow. Okay. Got hosed
So
by
this
reading.
this yeah this SAT question. Okay, dot r. So we don't need that. It's just literally dot append at index. How do you append at index? Is there a way to like insert into a specific index in Python? I don't think so, right?
Yeah.
Wait, what is it?
You do array of index equals something.
Oh, yeah, that's classic. I can't believe I didn't think of that. Okay. All right, that should work. I think I fixed all the array of array issues.
Yes, it's you.
Let's see. Oh no, modular 0. Why am I modulating 0? What the hell happened here? So it's complaining that length is 0? Oh, it's because if you pop the actual
So
element.
don't pop the
Yeah, we can't pop it. Alright, no popping.
no more
Just
popping. You
set it
don't
to
need to pop.
none. Set it to none. Wait, where's my
Right.
popper? Self.array index equals none. I think that's good, right? Wait, why is it
Okay, then
still?
you're initializing everything to none at the beginning, right?
Isn't it already none? Oh, it's not initialized. That's why.
So it should be none for I and K.
It's still wrong.
No, it's fine.
No. It's still thinks it's true.
Then return false if it's
Wait, what do you mean? It's the logic. All right, which one is this?
It's NQ. In Q, you're always returning true, which is not always the case.
No, I'm not.
Basically,
Oh, I am.
if it's full, you should
Oh, I
return
forgot to
false.
check for that. Okay, yeah, that's
Yeah.
right. Okay, so if yeah, we didn't think we thought it's never
But
full
you know,
basically. Okay. All right, now we need a custom test cases. Do we need
oh,
custom
so
test
boy,
cases?
amazing.
Oh no, I don't want to write a custom test case. That's so annoying.
Huh.
I should,
I mean,
I just hit submit and see what happens.
ah, just try it. Just try it.
Nope,
It
output
looks
limit
good.
exceeded. What? Wait, do I have prints? That's
Oh
probably
shit!
why. Yeah, I have prints.
Don't print.
Yeah,
Don't
no print, no printing.
print gets you hosed.
Oh, there we go. Hey, we done it in like 1 hour and 10 minutes.
No, no, no. Well, you did the more advanced problem, which is circular queue with which is always addable. No, this is a very involved question. I think this is on the order of those Google interview ones. So
Wait, really?
this,
This didn't
yeah,
seem
no.
that bad. It's just like.
I really like design questions. Like you think about small parts and how they fit together. Right?
No, no, no.
So
I these are much easier to me logically than
I
like a
agree.
stack question or whatever.
But as you become like more senior of a developer, design becomes very important. So this is very very useful, and you have to think about how things work with each other, how you can modularize and call them. Like adding this front helper and rear helper thing, that was not necessary in here, but like it helped make the code easier. So like all of this is very good. I think one feedback is that you know uh, maybe be a little bit more clear in your ideas before jumping in, because then you otherwise you get muddled in you know these small steps, right?
Yeah, I'm always like that though, even at work.
I don't know, but overall, I would say the logic was pretty clear, and you know, you were able to like by making the code modular, you could adjust it from the wrong interpretation to the correct interpretation pretty readily, right? Like it took you like a few minutes to fix
Because I was just
the
yeah, I was just
problem.
removing all the array stuff, and
Yeah,
it was
yeah.
just
So,
pretty
so
simple.
this is very good. Um, yeah, I think you'll just get better with at this over time. So,
Yeah.
but I would say this if I were grading this as a module for myself, right, this would be like a medium pass or low pass, right?
Okay.
So yeah, it's pretty good.
All right. Yeah. I think the only thing is I need to get used to it is like, because when I'm developing by myself, like when I'm thinking to myself and it's like wrong, obviously it's wrong. I figure it out. But when someone interviewing, they immediately call me out on wrong, and I'm like, oh shit. Yeah, I kind of knew that, but I wanted like a bit more time to think about it. But yeah, I guess.
No, that's fine.
Yeah.
No, it's good. You have test case. So I think this line 3 in the comments is very useful.
Yeah.
So have a little example that you can walk through for yourself. If
Yeah.
you
I
oh
always do that for like for like algorithm questions. I try to like run through my code to see if it works. Yeah.
But yeah, this is very good. It's very modular, very clear, very readable. I think the hard part was getting you to use offset in
Oh
your
yeah,
online
no,
version.
because when you were saying it, like I didn't fully grasp what you were saying. I knew there was an error with my code. I was trying to think of way to handle it, and you kept saying offset. I didn't really understand what you were saying at first, and then when you explained what it was, I was like, oh yeah, yeah. That's kind of what I was trying to go for. I just couldn't like word it out myself.
Oh, that's good. No, I would say you're in you know there's obviously work to be done, but you're in a pretty good starting position. So
Yeah. Okay. Cool.
okay, cool.
All right.
This was definitely much longer than the standard question, I think. So,
Yeah. Got hosed, and
but
going home
as you get
today.
better at this, you'll be able to do this in the standard 40-minute interview that they give you. So,
Well,
Cooler.
I'm sure isn't the standard. Like this is probably like part one. There's probably like a part two in the
No,
free
no,
one.
no, 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 no. For something this involved, this would probably be the whole thing.
Oh, really? You think so? Oh, okay.
This
Because
is
this didn't
this is
seem that bad
okay.
as I think. Like if I like didn't mess up so much, I probably could have solved in 40 for sure.
Yeah, exactly. The idea is that as you get better at this, your thoughts become clearer, and you
Hmm.
can verbalize it as much more, and you're also more organized. And then when that all happens, then you'll save like minutes here and there.
Hmm. Okay. Cool. All
Very good, very
right.
good.
All right.
Awesome.